All right, so here we go. Our last part. Hopefully this will be the last one. Graph the solution to the inequality 3x plus 6y is less than 18. All right, so here again, what am I going to do? I'm going to put it into slope-intercept form. So let's rewrite the problem. I'm going to subtract 3x from both sides because I want to get that y isolated by itself, and 3x minus 3x is 0. Bring down 6y is less than. Again, I'm going to put this x term first because I want it to be in y equals mx plus b format. Divide both sides by 6. Remember, every term needs to be divided by 6. We get y is less than. 3 over 6 is the same as 1 half, so negative 1 half x plus 18 divided by 6 is 3. All right, now I have a less than sign, which means it's going to be a dotted line. I have a negative slope, which means it's going to be a dotted line going down. So I'm starting at y equals 3. That's my y-intercept, going down 1 over 2, down 1 over 2, down 1 over 2. If you want to draw some dots the other way, up 1 over 2, up 1 over 2. And then again, it's going to be a dotted line. And now we need to decide which side of the line am I going to shade. Well, again, we always can test the easiest point. Let's test 0, 0. So let's see if that works. So 0, if I plug it in for y, is less than. Negative 1 half times 0 is 0 plus 3. 0 is, in fact, less than 3. So check. This one works, which means then I can go ahead and shade this entire region. That's it. Okay. Number 4, Jody is working 2 jobs, one as a carpenter and one as a web designer. He had worked at most 50 hours per week and made $35 per hour as a carpenter and $75 as a web designer. He wants to make at least 2,350 per week, but also wants to work at least 10 hours as a carpenter. Let C represent the hours he works as a carpenter and W represent the hours he works as a website designer. The graph below, to the side here, shows the constraints from the situation above. Name 2 possible combinations of hours he could work at the job given. So here they've already shaded in the part that is overlapping. Now notice in this situation we actually have 3 constraints. We have this line here, which is more than 10 hours as a carpenter. We have this one here. And then we have this one here, which shows the hours per week. All right, and so this shaded area is the area that shows our solutions. So 2 possible combinations, and looking at this 11, 32 is probably going to be a solution in that shaded area. Looking at 10 is here, right? So going up 11, going to approximately 32. So I'm going to say 10, 32 is one potential, which would be 10 hours as a carpenter and 32 hours as a web designer. Moving on a little bit further, right? Like 50 is all the way over here. So, I could move to maybe 15. Okay, so looking at 15 comma 31 is here. 15 comma 31 point 3 is another one. 15 hours as a carpenter, 31.3 hours as a web designer. All right, so anything that you can imagine being in this or that you can deduce is in this shaded area would work. It says, what are the 3 inequalities we use to represent this scenario? So I already started to talk about that. So we have at least 10 hours, okay? So C has to be greater than or equal to 10, right? The number of hours he's working as a carpenter is greater than or equal to 10. So imagine then that this side of that line would be shaded. Then the other one is hours per week. So that would be C plus W has to be at most, so less than or equal to 50. And so that's this line right here. And if it's at most less than or equal to, then in this case, I'm shading under the line here. And then the last line is, pick a different color so we can see it. This line right there, okay? And that is looking at our equation of 35 per hours as a carpenter plus 75 as a web designer, and at least, so greater than or equal to 23.50, because this is our money, right? 35 an hour, and we have to have money equaling money. This is greater than or equal to, and so 0, 0 would not be greater than or equal to, which means the other side of the line is what we're going to shade. So then for this one, we're going to shade this side of the line. So now you can see that where the overlap is where they shaded for us, right? But those are the three inequalities that we are looking at in this scenario. Number 5, Miss Lee makes earrings, sells them at the farmer's market and sells them. Sorry, there's a typo there. The cost to rent a booth is $150. The cost to make each set of earrings is $2 per pair. She sells the earrings for $10 a pair. So they're giving you the equation here. It says this equation represents the situation. If Miss Lee sells 20 earrings, will she make a profit? So in order for this to be true, for me to make a profit, then this side needs to be greater than the other side. So let's plug it in. If we plug in 10 times 20 earrings is greater than 150 plus 2 times 10, right? Because this represents the costs that I have, the booth and the making of the earrings. And then the other side represents my revenue. So this would be 200 is greater than 150 plus 20. 200 is greater than 170. So yes, she would make money because her earnings or revenue are greater than her costs. So the amount I'm spending on the booth and the earrings, making them, is less than the amount I'm going to rake in if I sell 20 earrings. All right, number 6, Malachi has a tutoring business. He gets $20 per hour for tutoring in math. I'll make that X. And $10 for reading. He is only allowed to work at most 15 hours per week. So we have X plus Y is less than or equal to 15. And we have 20X plus 10Y is, let's see, he wants to make at least 150. So greater than or equal to 150. Make a system of equations or inequalities to represent his situation. So we made the inequalities. We could also probably say that X and Y have to be greater than 0, assuming he's going to do both jobs. But it doesn't say that here, so maybe not. So we're going to put this in slope-intercept form so we can graph it. And this will be X plus Y is less than or equal to 15. Subtract X from both sides. We'll get Y is less than or equal to negative X plus 15. All right, that's my one graph. The other graph is going to be 20. Oh, I didn't put X. X plus 10Y is greater than or equal to 150. Subtract 20X. And we get 10Y is greater than or equal to negative 20X plus 150. Divide both sides by 10. And we get Y is greater than or equal to negative 2X plus 15. All right, now I can go ahead and graph these. Now for the first one, we're starting at 15. So I'm actually going to do these in increments of 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, I'm going to actually do this in 3, 6. No. I'm going to do it in twos. 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. All right, so 15 went between 14 and 16. We're going down 1 over 1. Okay. So this is our graph, okay? And it is less than or equal to, so it's a solid line. And then we want to go ahead and shade. So if I plug in 0, 0 to see if that works, 0 is less than or equal to 0 plus 15. That is true. So in this case, I'm going to shade this side of the graph. All right, let's graph the other one. So we're starting at 15 here too, except now we're going down 2 over 1. So down 2 over 1, down 2 over 1. Oh, I went over more than 1. Oh, that's going to erase the whole thing. Oh. Okay. Down 2 over 1, down 2 over 1, down 2 over 1. Okay, and so this time, again, we have a solid line as well. And now in terms of it wants to be greater than, so if I plug 0 is greater than or equal to 0 plus 15, that is not true. So in this case, I'm not going to graph this side. I'm going to graph the other side of the line, or shade in the other side of the line. And so that will be this side over here. And so our overlapping area is this triangle right in here. Okay. So there I have graphed it. All right, that is it for this. Your code word will be piano today, since I was sitting in the parking lot at piano practice. Happy homeworking, and see you tomorrow.